Hey Watkins, today we're looking at Wednesday, April 17th, Graphing Polynomials Part 2, and that's on page 73. If you would, update your table of contents. Okay, now your table of contents are updated. Let's take a look at the notes. Graphing Polynomials Part 2. Finding the rational root steps. Step 1. Use the rational root theorem to identify possible rational roots. The rational root theorem. If the polynomial p of x has integer coefficients, then every rational root of the polynomial equation p of x equals 0 can be written in the form p divided by q, where p is a factor of the constant term of p of x, and q is a factor of the leading coefficient of p of x. Step 2. Test possible rational roots using synthetic division. Refer to page 27 for synthetic division notes. Step 3. Repeat synthetic division to the new function until it is a quadratic ax squared plus bx plus c. Step 4. Once it is a quadratic, either factor or use the quadratic formula. Alright, now your notes are complete. Let's take a look at the examples. Alright, find the following information for each polynomial and then sketch a graph. So the degree name is cubic. The leading coefficient is 1. Number of terms would be 3 minus 1, which equals 2. It's an odd degree. And then the y-intercept. Now to find the y-intercept, we need to subtract 24 from both sides. Okay, so then that's 1x cubed plus 3x squared minus 10x minus 24 equal to 0. Now, the reason we need to do that to find the y-intercept is when x is 0. So we need to substitute 0 everywhere for x. So that's 0 cubed plus 3 times 0 squared minus 10 times 0 minus 24, which equals negative 24. So the y-intercept is 0, negative 24. Okay, now to identify the zeros, okay, let's first try to factor. So it looks like we can factor out an x squared from each term, so that's 1x squared, which leaves x plus 3 okay. Now it looks like we can factor out negative 2 from these, which leaves 5x plus 12 equal to 0. Now you see here that these are not the same, so this is not factorable by grouping. Okay, at this point, we need to do P and Q. Okay, now P is all of the factors of negative 24, which is plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, and plus or minus 24. And then Q would be plus or minus 1. Okay, now we need to do P divided by Q. Well, divide by 1, you still have 1, 2, 3, 4, 5, 6, 8, 12, and 24. So that's plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, plus or minus 24. Okay, now we need to use these factors along with synthetic division to find the zeros. Okay, so synthetic division, we're going to use this, so that's 1. And actually, let me move that over just a hair. 1, 3, negative 10, negative 24. All right, now the number we usually would put is right here, but because we're going to use multiple terms, we're going to have a chart here. We're going to use synthetic division repeating on these lines, okay? So let's start with the first factor, 1. Okay, so we bring down the 1. 1 times 1 is 1. 3 times 1, or 3 plus 1 is 4. 1 times 4 is 4. Negative 10 and 4 is negative 6. 1 times negative 6 is negative 6. Negative 24, negative 6 is negative 30. Now, our goal here is to get a remainder of 0. If we get a remainder of 0, then we know that this is one of the roots or factors, okay? Since we didn't, 1 doesn't work. We're going to repeat synthetic division using each of these factors until we find a remainder of 0, okay? So now let's try negative 1. So again, bring down the 1. Negative 1 times 1 is negative 1. And you might write really light here because you're going to continue to erase this until you get it. 3 minus 1 is 2. Negative 1 times 2 is negative 2. Negative 10 and negative 2 is negative 12. Negative 1 and negative 12 is a positive 12, which is a negative 12. So that didn't work. So let's move on to the next factor. Okay. So now let's try positive 2. So bring down the 1. So 2 times 1 is 2. 3 and 2 is 5. 2 times 5 is 10. 0. 2 times 0 is 0. Negative 24. That did not work. So let's try negative 2. Okay. Bring down the 1. Negative 2 times 1 is negative 2. 3 minus 2 is 1. Negative 2 times 1 is negative 2. Negative 10 and negative 2 is negative 12. Negative 2 and negative 12 is a positive 24. Negative 24 and 24 is 0. Okay. Now, since we have a remainder of 0, we know one of the roots or factors is x equals negative 2. Okay. Now, we did start with x cubed, but when we use the division, the degree decreases by 1. So now this is 1x squared plus 1x minus 12 equal to 0. And we can now factor this. We know x and x make x squared. And we need to find the combination that makes negative 12 and combines to be positive 1. So we know that -1 times 12 is -12. -1 plus 12 is 11. That didn't work because we're looking for a positive 1. -2 times 6 is -12. -2 plus 6 is 4. Didn't work, we're getting closer to 1. -3 times a positive 4 is -12. -3 plus 4 is 1. That works. So our factor of x minus 3, x plus 4. Okay, now we're going to set those equal to 0. So x minus 3 equal to 0, x plus 4 equal to 0. So x equals 3 and x equals -4. So our zeros are 3, 0, -4, 0, and -2, 0. Now our end behavior, we need to sketch a graph first. So we have a -2. We have a, almost forgot, a -4. So let me move this over. And a positive 3. Okay, now we know that since the leading coefficient is 1, that it's increasing from left to right. Okay, and it has 2 turns. So 1 turn, and it's probably actually going to go through like this, and then 2 turns. Now in behavior, as x approaches -infinity, means it goes left. F of x approaches -infinity, meaning going down. Okay, now as x approaches positive infinity, that means going right. F of x approaches positive infinity, meaning going up. All right, go ahead and finish up example 1. All right, now let's take a look at example 2. All right, the degree name is quartic. Leading coefficient is 4. Number of turns is 4 minus 1, which equals 3. Now, even or odd, it's even. Now, the y-intercept is when x is 0. So we need to substitute 0 in for x. So that's 4 times 0 to the 4th minus 21 times 0 cubed plus 18 times 0 squared plus 19 times 0 minus 6 equals 0. I'm sorry, just equals -6. So your y-intercept is 0, -6. Okay, now this has 1, 2, 3, 4, 5 terms, so we know it's not factorable. Or you can just write NF. Okay, so now we need to do P divided by Q. All right, so we need to find all the factors of -6. So that's plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. And then Q, this is where it gets fun and interesting. Q, the factors of 4 are plus or minus 1, plus or minus 2, and plus or minus 4. And I guess I could have, but our factors are 6 and 4. Probably should have written them in front of the P and Q, but nonetheless, we're trying to find the factors of 6 and 4. Okay, so now we need to do P divided by Q. Okay, so when we divide by 1, 1 divided by 1 is 1, plus or minus 1. 2 divided by 1 is plus or minus 2. 3 divided by 1 is plus or minus 3. And then 6 divided by 1 is plus or minus 6. Now we need to divide it by 2. So 1 divided by 2 is plus or minus 1/2. 2 divided by 2 is 1, which we already have. 3 divided by 2, so plus or minus 3 divided by 2. And then 6 divided by 2 is 3, which we already have. Okay, now we need to divide by 4. So 1 divided by 4 is plus or minus 1/4. And then 2 divided by 4 is 2/4, which is 1/2. 3 divided by 4, so plus or minus 3/4. And then 6 divided by 4 reduces to be 3/2. So these are all the factors. And, all right, so now we're going to use synthetic division. So 4, -21, 18, 19, and -6. All right, now what I suggest doing is graphing this to see if we can find the first factor to see which one to start with. So let's take a look. All right, so let me adjust the camera here, darken it a little bit. There we go. So I'm going to go to add graph. And now we're going to graph 4x to the 4th minus 21x cubed plus 18x squared plus 19x minus, oh, forgot something, minus 6. All right, so adjust the focus here. It looks like we have a factor at +2. And let me make sure I got this graph correctly. 4x to the 4th minus 21x cubed plus 18x squared plus 19x minus 6. Okay, so yeah, it looks like +2 is probably one we should start with, okay? All right. So, bring down the 4. 2 times 4 is 8. Negative 21 minus, or 21 and 8 is negative 13. 2 times negative 13 is negative 26, which is negative 8. 2 times negative 8 is a negative 16. 19 minus 16 is 3. 2 times 3 is 6. So we have a remainder of 0. Okay. Now, the problem is we can't factor because now this is 4x cubed. Okay. So we need to go down one more. So let's take a look at another 0. And so it looks like we have that negative right there. So let's go ahead and find the 0. So menu, and again, I'm using the calculator to try to expedite or speed up the process. Otherwise, you'd have to go through every single one of these combinations. That would take almost forever. Okay, so we're going to go to Analyze Graph. We want the 0, click, and drag, and you can see that, Control click, this right here is negative 0.75, which we know is negative 3/4. So that's going to be our next choice. So negative 3/4. Okay, so we bring down the 4. Actually, I'm sorry, we need to start a whole new synthetic division. So negative 3/4 here. And the reason being is this is now the reduced form of that. So we're going to use synthetic division again to try to reduce this and also see if this is a 0. So we bring down the 4. Negative 3/4 times 4 is negative 3, which is negative 16. Negative 3 divided by 4 times negative 16 is positive 12. That combines to be positive 4. Negative 3/4 times 4 is negative 3. Remainder of 0. Almost forgot to write x equals 2 is one of these zeros. So now we can say that x equals negative 3 divided by 4 is one of these zeros. Okay, now this was x to the 4th, x cubed, now x squared. So now we have 4x squared minus 16x plus 4 equals 0. And we can now factor this, okay? So we can divide everything by 4, so we can factor out of 4, which leaves 1x squared minus 4x plus 1 equal to 0. Now, this is not going to be factorable because there's no combination of multipliers we want to give you negative 4. So we're going to come back here and use the quadratic formula. So x equals negative 16 plus or minus the square root of negative 16 squared minus 4 times positive 4 divided by 2 times 4. Okay, so let's go ahead and plug that into the calculator. New documents, no. Add calculator, control divide. Well, that's just a positive 16 plus control square root of parentheses negative 16 squared minus 4 times 4 times 4 divided by 2 times 4. So x equals, let's say, 3.7. Highlight. If I can highlight, enter. Change the plus to a minus. And x equals 0.3. Okay. So we have, let's add an extra line here because we have several zeros. Okay. So we have 2 comma 0. We have negative 3 divided by 4 comma 0. Now we have 3.7 comma 0 and 0.3 comma 0. All right, go ahead and finish up example 2. Okay, now let's move on to example 3. Too far. All right, so degree name is cubic. Leading coefficient is negative 2. Number of turns is 3 minus 1, which equals 2. Now, even or odd, it's odd. The y-intercept is when x is 0. So then that's negative 2 times 0 cubed minus 12 times 0 squared plus 30 times 0 plus 200 equals 200. Now, let me pause that for a moment because I almost forgot. With all that fun of getting all the zeros, we forgot to sketch our graph. Okay, so this is negative 3/4. This is 0.3. Okay, and then this would be 2, and this would be 3.7. Okay, let me rewrite that 0.3 a little bit better. All right, now we know since it's quartic and the leading coefficient is positive, we know that it opens upwards. And we know that it has 3 turns. So 1 turn, 2 turns, and 3 turns. Okay. I can't believe I almost forgot the most exciting and fun part of example 2 was sketching the graph. But there it is. And with that, let's look at the end behavior. So x approaches negative infinity. F of x approaches positive infinity. And as x approaches positive infinity, f of x approaches positive infinity. All right, now you can finish up example 2. All right, now let's take a look at example 3. Okay. All right, so here we have 1, 2, 3, 4. There's a possibility of factoring So it looks like we can factor a negative 2x squared out of here, which leaves x plus 6. And it looks like we can factor out a positive 5, which leaves 6x. Oh, we can actually factor out, I'm sorry. I almost didn't see the, no, that's right, plus 5 leaves 6x plus, see, 200 divided by 5 is 40. Now here, and I'm kind of doing this on purpose, is that you pick a number, but then you can see here that this can actually be factored out more, so we can actually factor out a 2 from each of these, so we could have actually factored out a 10. So when we do that, when we factor out 10, 30 divided by 10 is 3, so it's 3x. And then 200 divided by 10 is 20. And now this is factors you can do. But notice, these are not the same, so it's not factorable. So now we need to do P and Q. Now, what I should have done in the last problem here where I put the 6 and 4 here, I should have put the here. Okay, so we put the 200 here and the negative 2 here. Okay, so now we need to find all the factors of 200 and negative 2. Okay, so that's plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, plus or minus 20, plus or minus 25, and plus or minus 50. And 200 is one as well, but I don't think we need to worry about that one. And then all the factors of negative 2 are plus or minus 1, plus or minus 2. Okay? Now, okay, we need to divide by 1 here. So, we're just doing P divided by Q here. So 1 divided by 1 is 1, 2, 4, 5, 20, or 10, 20, 25, and 50. So plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, plus or minus 20, plus or minus 25, plus or minus 50. Now, I just noticed that we divided by 2 here because we were dividing 200 by negative 2. And you could do that, but a more efficient way is if we factor out the negative 2 first. That would be 1x cubed plus 6x squared minus 15x minus 100. Now, if we do that, then we can change here to 100, let's see, negative 100, and a positive 1. If you do that, then we cut out the 2, and then we can stop here, okay? All right, so now we use synthetic division, so that's 1. Now, because we factor out the negative 2, let's make our job easier. Let's use these terms, okay? So 1 6, negative 15, negative 100. All right, and again, so we don't have to go through all of the combinations. Let's graph it and find the first zero, okay? So on, new document, no, add graph. Now when you're graphing, you want to graph the original. So negative 2x to the third power minus 12x squared plus 30x plus 200. And it looks like we can start with negative 1, 2, 3, 4, negative 5. Okay? So bring down the 1. Negative 5 times 1 is negative 5. Might be 1. Negative 5 times 1 is negative 5. And then that becomes a negative 20. And then negative 5 times negative 20 is a positive 100. So that is 0. So we know that x equals negative 5 is one of the zeros. So now this was x cubed. Now we can factor this as 1x squared plus 1x minus 20 equal to 0. Now we know 2 parentheses, x, x, so now we need to find all the combinations to make negative 20 combined to be positive 1. So negative 1 times positive 20 is negative 20. Negative 1 plus 20 is 19. That didn't work. Negative 2 times 10 is negative 20. Negative 2 plus 10 is 8. That didn't work. Negative 4 times 5 is negative 20. Negative 4 plus 5 is 1. That works. So our factors are x minus 4, x plus 5. So x minus 4 equal to 0. X plus 5 equal to 0. So x equals 4. X equals negative 5. So our zeros are negative 5. I just don't know. I can't write negative 5 or 5s right now. Negative 5, comma 0. Now, that's multiplicity of 2. And we have 4, comma 0. Okay. Let me not forget the sketch from, like I did in example 2. Now, first off, the y-intercept is 0, 200. Okay. Now, it looks like we have negative 5. And then we have 4. Okay. Now, we know it's negative and it's cubic, so it's going down from left to right. Now, this multiplicity is important because at this point it touches and turns. Okay? And then it turns back through to 4. Okay? So now our end behavior, as x approaches negative infinity, f of x approaches positive infinity, and as x approaches positive infinity, f of x approaches negative infinity. Okay, if you would, go ahead and finish up your examples, start working on your assignments, and have a wonderful Wildcat day.